Hello, my name is Christos Ellinas, and today I'm going to talk to you about the failure of predictability and the risk management in the context of engineering. And to begin with, I just want to get your attention with this quote by Laplace, who basically encapsulates our trust that we have in the science, that as much as we know, everything we can predict as far as we want. And this has been a quote 200 years ago, and I'm just here to talk about the validity of this quote in our society. And for those of you who don't speak Greek, my last name actually means Greek, so I'm kind of bound to begin with Greek methodology. So back in my ancient ancestors, there was no need for risk management, just because everything was the act of God, and thus you cannot predict. Thus, no point in trying to predict. But then, as we started learning more and more about how the world works, we kind of reached to a conclusion that actually we can almost predict everything. We live in a clockwork universe. And this was up to the 1960s, and up to that point, people started beginning to realize that non-linear systems effectively are not the exception, but rather the rule. But the issue that I see is that the risk management hasn't really kind of evolved into this situation. Like, risk management basically is built upon the paradigm that you identify and assess the probability of something happening and the impact that it will have on you. But then it kind of seems a bit of a broken paradigm, as we actually now know that what matters actually we cannot predict. And we're living in a situation right now that it's unaffected by that. And I want to introduce that concept in the context of engineering. And to begin with, I'm just going to use a very simple system, which is just a transistor. And it's a designed system, it's a very easy system to work with, and it's a simple system for a simple problem. And how would you do risk management on this? Well, actually, you don't really need any risk management because you can predict what it's going to do. But then once you start putting them together, you can actually get increased functionality, which is basically the idea of the smart grid. Like, to put stuff together, it's not something new. We just, as engineers, we like to couple systems to get increased functionality with just less resources, effectively. And once you start putting all of this together, you get a complicated system which can deal with a complicated problem. But then the trouble with that is that you have thousands and thousands of variables. And how do we deal with them? Well, basically what we do is we aggregate things. And aggregation works just because you have a very nice normal Bell distribution. Everything aggregates to a mean, you use the average, and thus you get your answer. And this is where physicists became very successful with statistical mechanics and all of these techniques. But then the problem is, this is systems that we can actually design, and we are designing, but what we want to design are systems like this. What happens when you take out complicated systems, you put them together? So you get actually an evolving system rather than a design system. So you can't really inflict a top-down architecture onto it. And these are systems that actually our whole society is built upon. And then if they are such vital systems, then why hasn't the risk management actually guide us through not to fail while designing these systems? And what we are working upon is basically a new, I don't want to sound very optimistic, but it's a kind of new approach into risk management. It's not focusing on identifying and assessing, because the idea is what happens if you have low probability, high impact risk materializing. And just simply because we couple things together, one failure to one system will propagate to another. And I'm just going to show you some systems that are basically dominant in our modern society right now. So you have supply chains, you have power grids, even social networks, and all of these systems, the use of these illustrations is very on purpose. Like, you can see that you can represent most of them with a very specific framework, which is networks. And this is a tool that has been emerging in science for the past decade, and scientists are beginning to uncover universal properties within all of these systems. And my question here is, if scientists are uncovering characteristics of these systems that we design, then how come we have all of this knowledge on that domain which is not being transferred to engineers? And it's engineers who design the system, but it's scientists who understand the system. So why is there this pressure? Because you can see all of these systems and actually identify major risks that have materialized. Like, you have the horse meat incident in the supply chains, you have, I don't really have to speak about the economy, you have power grids, you have like, you know, if a recent failure in the States, a tree just fell on a power line and 50 million people were out of power for 3 days, which is not an amazing thing to have. So I just want to end up with this question. So we know what kind of systems we want. So we want complex systems. We want increased functionality with less and less resources, because the way we made our planet now, we have less and less resources. So if these are the systems that we want to design, and there are people who know how, there are some universal characteristics, then why aren't we using that knowledge to benefit from it? And you know, this is, as the director of EPSRC mentioned, that this is an ideal time, just because we're encountering a lot of failures in the sense of all of these systems like we have, well, as I mentioned before. So this is actually an ideal time to sit down and focus and understand why risk management is completely failing us to deliver all of these monumental projects that we really, really need as the smart grids and all of these kind of really big projects. So I just want to end up with, you know, just an observation. You know, we are in a crisis. We are in an engineering crisis. Like, we are in the face of technology stagnation. We have all of these issues that emerge, which are really big issues. And it seems to me that rather than building windmills, we are building walls between knowledge domains, which is a very sad thing to experience. And that's the note I want to end this presentation with. Thank you.